Hello, in this third video in the series, we're going to be taking a look at survey data import and checks and dealing with warnings. The general process for importing data is to set up a project with an appropriate template containing a number of settings and tolerances, generally user-defined, to import the survey data, review and address any import warnings. The TBC computations engine will then take over and generate coordinates for all the points in the project. The operator should then perform any data checks applicable and review and address any warnings reported for the data in the project. The data, survey data, will typically come in a job or a JXL format if from a Trimble survey device. Raw GNSS data would be in a T01, T02 or possibly T04 format. Trimble DINI digital level data in a DAT format, although it is possible to import into TBC file types, survey file types from non-Trimble software as well. All of these files can be imported into the project by a drag and drop action or to use the import function, and the data will be checked on import. Warnings that might appear during the import process include missing data files, so files that were associated with the survey in the field but are not present in the data source that's been imported into TBC. So this could be missing code library files, missing media files, JPEGs or scan files, or missing raw GNSS data files. Coordinate system anomalies and information about deleted or disabled observations might also be reported at the initial import stage. The TBC computations engine will compute initial coordinates from the imported survey data following the sequence of observations made in the field. It should be said that station setup backsights can be reassigned for tilt station data if it's necessary to switch from an existing backsight to a measurement to use as an alternative backsight. So without any traverse or network adjustment of the data, then the computations engine will compute a coordinate for a point based on the data quality hierarchy within the survey. The hierarchy is control, survey, mapping and unknown. Coordinates that are in the project, either from the survey field data or that are created subsequently, can be assigned one of those values. Survey device measurements are assigned survey quality, and the highest quality data for a point provides its computed coordinate. That would start with coordinates that are in the project and then move on to measurements. So for example, if there is a coordinate present in the project for a point that has control quality and a number of survey measurements, it's that control quality coordinate that will be assigned to the point. If there is no coordinate present in the project, then a coordinate will be generated from the survey data present. Generally speaking, if a traverse or network adjustment takes place within the project, then these will take precedence over computation engine initially derived coordinates. So when all the data for a point has equal quality status, for example, a series of measurements which all have survey quality, there's no coordinates present for the point that have been imported or keyed in, then the computed coordinate will be assigned based again on the following hierarchy. So if there's a coordinate present, that will be used. If there is no coordinate present, then any GNSS observations will be used to assign a coordinate to a point. In terms of an elevation, digital level data would then come in next. And finally, if there's no coordinate GNSS or level data, then coordinates will be computed from total station measurements present in the survey file. So in terms of checks, perform checks as per your usual company procedures. To some extent will be data dependent, but could include checking pole heights, precisions, instrument height, pole heights and prism constants, as was covered in the second video on the data viewing options in TBC. In terms of dealing with warnings, any warning reported either during the import process or once the import process is completed and the computations engine has generated coordinates for points in the project, all of these warnings need to be carefully examined and considered and, if possible, resolved. The warnings will appear in a flags pane or window, which appears at the bottom of the Trimble Business Center interface. Some of these warnings will carry over from the import report. So if there's a warning about a missing code library, for instance, that message will also appear in the flags pane. Warnings are generated when a station setup could not be computed, a point coordinate could not be computed, or values are out of tolerance. We can see here an example of a flags window, some survey data which we'll look at more closely later as an example of the data import process. See a number of warnings, including that a point GSC-C2 is out of tolerance in the vertical direction by a vertical distance of 1.6624 meters, and that's exceeded a vertical point tolerance which lives in the project settings. And there's a number of other warnings there as well, we can see. Taken from the Trimble Business Center help, there's a number of reasons why station setup, total station survey station setup couldn't be computed. So there might be some form of an identified problem. There may be no valid backsight measurements, or an azimuth value missing, or some computation error which prevents a resection from satisfactory computing. Typically, when a total station setup cannot be computed, it's often because a station setup has been aborted before the backsights have been measured or satisfactorily measured in the field, or perhaps they have been measured and then disabled or deleted. Second group of warnings would be about why point coordinates could not be computed, usually caused by deleted or disabled data. Thus, a coordinate for a station setup disabled, which means no further coordinates can be reduced from observations made from that station. And the same again if a backsight or critical backsight or azimuth has been disabled for a station setup. There could be some error in the field survey data, some missing information such as an angles only measurement, and coordinate systems and coordinates mismatched. So for example, perhaps you have a case where imported GNSS observations could be brought into a project which has an incorrect coordinate system assigned to the project, so it's outside the bounds of the coordinate system. And indeed, this sometimes happens when local site grid values are used within a national grid coordinate system. Out of tolerance warnings may be reported for points, angles and distances in measured rounds or measured rounds of angles, and for certain GNSS sensors which incorporate tilt sensors such as the R10, the R12 and the R12i, then any out of tolerance tilt distances will be reported as well. Point tolerance failures are reported when additional measurements to a point which will create or could compute a coordinate for the point are markedly different to the coordinate assigned to the point. So for all the data available for a point, one bit of data, a coordinate or a measurement based on the hierarchy of the data or the type of measurement will be used to compute an initial coordinate for the point. Any subsequent data or measurements that could provide a coordinate for the same point, they're used as a check. So here we can see again the same flags window and the vertical out of tolerance failure reported for point GS-CC2. To examine this further, you'd open a point derivation report, which looks like this, and essentially reports which observation has been used to assign a coordinate to the point, and any further coordinates or measurements to the point which can provide a coordinate for it are also compared to the assigned values. Looking into the table in the report, we can see that a grid coordinate in the JXL file has been used to assign easting, northing and elevation values to the point, and a global, which will be a GNSS observation, has been used to assign ellipsoidal height value to the observation. And following that, we can see a GNSS RTK vector being compared to the coordinate, a round of angles result, a face left measurement, again a round of angles and a face left measurement. So where the tolerance failure occurs, the values involved will be highlighted in red. So here we can see that vertical bust in elevation and ellipsoidal height, and it's as a consequence of this round of angles here, where we have some observations from station 07 FTSC3 to GSCC2, as a result of which these observations differ in elevation and height from the assigned coordinate by the values shown. You can see that looking at the other observations in the project which can provide a coordinate for GSCC2, they're all within tolerance of the order of just a few millimeters different from the initially assigned value. And again, this is before any traverse adjustment or network adjustment of the data in the project. Other types of tolerance failure might report to failures that relate to measured rounds of angles, so horizontal angle, vertical angle, or slope, distance, residual tolerance failures. The mean angles residuals viewer is the best place to look at the observations concerned where the residuals are being reported as out of tolerance, and using the check boxes it can be determined what to keep as enabled and what to disable as bad measurements from the rounds of angles. In the next part of the video, I'm going to use an example data set, some of the information we've seen in the dialog boxes in the slides already, to show how some of these errors and warnings can be handled and resolved in Trimble Business Centre. Here I have TBC open. I'm going to begin with a new project using a template which has my settings and tolerances stored within it as per the information in the first video. And to this project, I'm going to import a Trimble JXL format file which contains some GNSS RTK vectors and some total station observations. What a prompt appeared straight away about a missing geoid model file. This is typically a naming issue and is often the case. It simply means picking the required model from the list generated by the Trimble Coordinate System database and hitting OK to resolve the issue. Another issue has presented itself, quite a common one this, when using survey files and projects with coordinate system, that there's some anomaly or some difference between the coordinate system information in the survey file versus the coordinate system information specified in the project file. It's always a good idea to press details to review what the differences are in case there's anything critical. There's no lines highlighted in yellow in the file, so there's no standout differences, but what I can see, there's some question marks showing here, whereas over on this side there's some 0 and 1s, but there's nothing here which would dictate a significant difference between the project database coordinate system settings and the imported file settings. So in this case, I could select either system to go with, but I will go with the project definition coordinate system settings. It's quite a large file, a topographic survey, so it's going to take a moment or two to import. Checks have been applied to the data during import. A number of warnings related to the imported file have been generated. It's always recommended that if this dialog box appears about import warnings or import errors, to press yes to view the information being reported. So error number 1, this has been dealt with. We've selected the correct geoid model name from a drop-down list geoid models in the Trimble Coordinate System database. There are then a large number of warnings. Mostly it appears relating to missing JPEG files. So these will have been perhaps photos that were taken during the survey and associated to point data in the survey which have not been present or available at the data import stage. If these JPEGs, of course, are required, then they would need to be put into the appropriate folder alongside the JXL file when the JXL file is imported, so that the JPEGs import as well. But in this example, I don't have the JPEG files, only the survey data, so the warning is valid. There are 2 more warning messages here. There's information regarding station point name TSCC4, which is station setup number 12, and a set of mean angles recorded for this station, where set 1 and set 2 of the rounds of angles made at this station contain redundant or disabled measurements. And we'll come back to this one in a short while. There's also a report that the feature code library, the .fxl file, has not been located again with the survey data at the data import stage, so it's reported as unavailable or missing. And there's just a message here regarding the coordinate system selection to use the project coordinate system definition. So there's the import report with some initial warnings related to the import data, which could be printed to a PDF for further record keeping. I'll begin by addressing the issues highlighted here. The redundant backsight observations in round of angles reference M18, station setup 12, and the code library not coming in with the survey file. Minimize the report. Here is the survey data. Project Explorer is open in the properties dialog, and from video 2 we know we have the other data viewing windows available should we need to use them to inspect target heights, prism constants, instrument heights, etc. for a broader selection of data. So within project, in the imported files section is the JXL file. You can see the data recorded in sequence of measurement in the field survey. So we can see it began with some RTK observations. Here are the RTK vectors from this base. Then some total station measurements. There's a coordinate present here. Some more total station measurements from additional setups. And moving down, we can see all of the survey measurements listed in the imported file. So we're looking at setup 12 for point TSCC4, 12th station setup in the project, and we can see all the rounds of angles recorded here, the mean angle result for the measurements between TSCC4 and TSCC3. So that message we saw a moment ago is essentially saying that in set 1 and set 2 there are disabled measurements. So there'll be some measurements which are disabled and some measurements that aren't disabled. Now, of course, the measurements that haven't been disabled in the field, these will be the ones that are being used to compute the mean angle between TSCC4 and TSCC3. What TBC is doing is warning that because some of the measurements to other points in the round, in this case TSCC5, have been disabled or deleted, is it still valid to use the other measurements in the same round? Now that's a question as a surveyor that you need to examine and decide based on the surveyor's information, field information, as to whether the other measurements that haven't been deleted are still good. So within set 1 here, are the measurements to TSCC3 still good, even though the measurements to TSCC5 have been deleted? If it's decided to be on the safe side and to remove or disable the measurements to TSCC3 as well in these two sets. That is what the function was referred to in the import report name disable redundant backsights. So in essence, where you have a round of angles and there are some disabled measurements within that round, running this function will also disable other measurements within the same round as the disabled measurements. If I right click and look at the mean angle residuals, you can see currently that there are 6 measurements from TSCC4 to point TSCC3. And we know that some of these measurements will have come from set 1 and set 2. Indeed, we can cross-reference by their observation ID, T1579 for instance, we can see was in the round of measurements labelled set 1. So it may be that these measurements are absolutely fine to keep and that command doesn't need to be run, but TBC is at least flagging up that there are a combination in that round of disabled and non-disabled or deleted measurements. If a right click is made and the option is selected to disable redundant measurements, if we look at the mean angle residuals now in the table, we can see that the measurements to TSCC3 in set 1 and set 2 have been disabled and only the measurements from set 3 have been retained. When a red ball appears at the bottom of the screen in TBC, a recompute of the project is available to perform, so all of the coordinates in the project will be recomputed using the computation engine. Having done the recomputation, you can see that the updated mean angle result from TSCC4 to TSCC3 is very similar to the values that existed prior to running the disable redundant backsights function. So the measurements that were there from set 1 and set 2 were probably okay. Before turning some attention to the other flags or warnings now displayed in the flags window, now take a look at the data on the plan view. You can see that RTK vectors coming in from a VRS base station, the long blue lines. Zooming in, as it's a relatively large survey, we can see lots of point labels here. At first glance, it's kind of hard to see the wood for the trees with all these labels showing. So using the View Filter Manager, for the time being, I'm going to untick Show Point IDs. And then we can see positions in the data relating to measurements which have flags related to them in the table down here. By hovering the cursor over a particular flag, it's possible to see, well, the observation it relates to, or observations in this case, and the flag warning itself. Okay, it's still quite busy with these green radial lines, which are the total station measurements to detail points. Again, in the View Filter Manager, it's possible to turn those off. And indeed, in the observations section, it's possible to untick Show Side Shots. a little bit easier to see what's going on now. It would be possible to turn off the remaining RTK vectors as well, if desired, using the tick button here. And sometimes I will put the base point on a layer of its own and turn off the base point if I don't want that interrupting my navigation of the data. So yes, putting that base point on a layer of its own and then turning off that layer is a good way of doing that. Okay, the remaining warning messages here for this video as a good example of real life situations that might arise. Run through these and try and clear them one by one. The first one is potentially the most tricky by the looks of it. We've got a vertical out of tolerance, a large value, and the value in question, 1.662, would normally be something in the range of a station setup height or a pole height, something of that nature. So I'll click on the warning message. We'll see some point information for GSCC2. Next, I'm going to right click on this row in the warning flag window and select the option to open a point derivation report. I'm going to drag this report across so it's visible. You can see here that the coordinate that's been assigned to GSCC2 has come from the grid value here with survey quality grid coordinate in the JXL file, and there's also an ellipsoidal height value in the JXL file as well, which has been used to provide the ellipsoidal height. The observation or the record which pertains to the out of tolerance warning is for this row here, and we can see it relates to some measurements in a round of angles, mean angles, round 43 in the project, from a station named 07FTSC3. So it's an observation or observations from this station in this round of angles to GSCC2, which don't tie in or chime with the other observations in the project. And we can see there's quite a number of observations, either check measurements or other rounds of angles, which also position GSCC2, but none of them are flagged in red, so they're all within a set tolerance similar to the assigned coordinate, whereas this one clearly is not. It doesn't tell us which station setup that round of angles relates to, so we're going to have to do a bit of digging in the Project Explorer, but we do know the round in question is M43, so we need to see what's going on there. So into Project Explorer, into imported files, and this being a relatively large topo, you can see there's actually lots of station setups. If I just sample one of the stations here, there's a measure rounds relating to that station. It's number 39, so we need to delve a little bit further on. And here we can actually see the setup that was highlighted in the report, or the point that was highlighted in the report, 07FTSC3. Expanding the info for this, here we can actually see round 43. So this mean angle residuals report will contain the observations shown here. We can also see that there's no detail measurements taken from this station setup. It was literally a setup, GSCC2 measured on phase 1 and then phase 2. GSCC2 had been set on just prior to that setup. We can see the observations there to TSCC3. It's possible to see that GSCC2 was set over again after the setup where there may be something erroneous or not quite right occurring. And then here again we can see another setup on 07F TSC3, which does have measurements to GSCC2 and detail observations. So the amount of information that relates to this station setup is somewhat limited, and we just have these two observations here. So looking at the properties of these, we can see that the instrument setup was given a 0 raw instrument height and a true height of 1.727 as the target height for the measurement GSCC2. That's the face left, and on face right it's the same story. Just looking a bit further on the setup here, also at 07F TSC3, we can see here that the instrument height was entered as 1.662, and 1.662 is the flagged out of tolerance setting here. So it may be that this station should have been given that same raw instrument height, and putting that in would certainly resolve the issue, but without input from the field notes or the surveyor, that can't be determined just from the data here, although given the sequence of station setups just described here, it's a possibility. But not knowing, given that there were no detail measurements from here and there's redundant station setups to carry the survey forward, in this case it might be wise to disable these two observations. I say disable rather than delete because disabling them will create new warning flags in the flags window, because if I disable both the backsight observations for the station setup, then the station setup is going to fail and won't compute, and that will be reported in the flags window. But it may be worth doing that, see if anything else is introduced into the data before deleting this setup as a whole. So I'll do that here now, change the status here to disabled, and this one. We'll press the recompute to let the computations engine recompute all the coordinates in the project, and we'll see what happens to the warning flag. Okay, that warning flag has now disappeared, but as anticipated, the station setup has failed to compute here with the backsight GSCC2 because I've just disabled those backsights. But it doesn't appear to have affected the data that would generate any of the warning messages. So again, without any input from the surveyor or any field notes to reference, it might be wise to go ahead in this case and delete this station setup. Again, having done that, we can recompute the project. Now let's turn our attention to the remaining warnings in the flags window. In the main, they all relate to failed tolerances for the mean angle residuals, both in the horizontal and in the vertical direction. The other one that remains is the reference to a code library that wasn't imported with the data. Of course, a code library can be brought into the project at any stage for processing of feature codes. It may be as well to locate that record in the imported files section, Project Explorer. I'll just right click and delete that, and that removes that flag, just leaving the mean turned angle residual failures remaining. Inspecting these, we have a setup at TSCC3, round of angles incorporating point TSCC4, and the mean angle residuals summary record is reference M10. So we could locate M10 in the imported file section of Project Explorer, but it's also possible for these mean turn angle residual issues here just to click on the line in question and then open the mean angle residuals viewer. Here we can see the residual that's causing the flag to appear, the warning to appear. Quite a difference between the residual for this measurement and the mean, so we can quite safely untick and effectively disable that observation from the round. And it's also asking if we wish to disable the face right measurement taken to the point as well. And perhaps it would be safest again to select yes. So the remaining 4 measurements in the round have now been reassessed. The residuals have been recomputed, and nothing now is failing the tolerance. So if I click OK here, that particular warning is removed. This one here relates to mean angle record M50. So again, you can look at the mean angle residuals for M50. It's set up at TSCC9. This time the error is in the vertical direction, vertical angle residuals. We can see we've got several here that are producing failures, but the values of the residuals for the face left and the face right measurements are very similar in magnitude, and they're in the opposite direction. So we have a negative residual here and a positive residual here. So in effect, these will cancel each other out. So the mean should still be valid. Now it could be that some collimation error in the instrument has caused this effect to appear, or it could be a viewing angle perhaps into the prism, perhaps at a bit of an oblique angle and not facing full into the prism, which has caused perhaps this effect to appear. But nevertheless, looking at the values, although they exceed the tolerances, because they're equal and opposite, it would be okay to keep those mean angles in, but it would certainly be a good idea to check the total station for collimation error that's been used to take these measurements at the earliest possible opportunity. So I'll tap OK here and leave those in place. We've got a very similar situation here at setup TSCC10, and again at TSCC11, in fact 2 rounds of angles results here. So it might be the same situation again. Let's have a look. Right click, mean angle residuals, and yes, we can see similar values as before, with the equal and opposite numbers for the residuals. So again, the mean result should still be good for the vertical angle, even though the residuals are showing a bit on the high side. Yes, it's the same situation here, and at mean angle residual results M61. Yes, equal and opposite. It's the same situation here, so we'll leave those in the project as well. If I was to untick an observation to take it out of the round of angles results, for example, observation 4969 in the project from TSCC 11, this is round of angles reference M61. I'll just do that. There's M60, so M61 is likely to be here. Okay, here's the round in question, M61, where my values were deleted. So the measurements must have originated in one of the preceding sets that contributed to this mean angle residuals result here. And there's observation 4969. And if I click on it, I can see that it is now showing that measurement as disabled. Here's the face right measurement, which has also been disabled. To re-enable these measurements back in the round, just go to mean angle residuals and tick these back on and OK, and I'll now recompute. Okay, having re-enabled those observations in the round, the previously examined warning flags have reappeared. But we've understood those, and we know the result of the observations here. So in this case, it makes sense to continue with the processing, even though we still have these warning flags left in the project. In this video, run through the process using an example dataset, importing survey data and addressing some of the warnings that can appear upon data import and computation within a TBC project. If you have any questions about the content of the video, please get in touch with ourselves on the details shown. Thanks for watching.